The imaginary unit I. Recall that the square root of negative 25 is not a real number. The square root of negative numbers are not real numbers. They're called imaginary numbers. So let's talk about this imaginary unit I. It is defined as I equals the square root of negative 1. In words, I is the principal square root of negative 1. Every imaginary number, in fact, has square root of negative 1 as a factor. The square root of negative 1 is called the imaginary unit and is denoted by the letter I. Let's do some examples evaluating negative square roots. So in the first example, we have negative square root of negative 100. So remember, every imaginary number has a negative 1 as its factor. So what you can think of it as negative 1 times the positive of that number. If we were to write it out, it will look like so. So you have square root of 100, there's the positive square root, times negative 1, we extracted the negative there. And you should know that 100 times negative 1 equals negative 100. So all we did was rewrite it in a different form. So just for the purposes of teaching, I rewrote it in this form so that you can understand the process. Solving the regular positive square root here, as usual, the square root of 100 is 10. And we know by definition that the square root of negative 1 equals I. So 10 times I, the answer equals 10I. Honestly, all you have to do is just solve the root as if it was positive and then attach the I to it if you have a negative square root of that number. Such as in the example of 2. If you think about the positive of that, square root of 64, it equals 8. Because it has a negative there, adding the I with it, it would equal 8I. But if you want to understand the process, again, I'm going to show you how it works. Every negative root, imaginary number, has negative 1 as one of its factors. So you have square root of 64 times square root of negative 1. And again, we know the square root of 64 is 8. The square root of negative 1 is I. Put it together and you have 8I. Let's do some more practice. Simplifying square roots of negative numbers. So here, if you do that same process, think of 81 in its positive. Square root of 81 is 9. With a negative there, it's going to equal 9I. However, you have a negative out in front, negating it. So it would have, the answer to this would have been 9I without that negative on the outside. But because you have that negative on the outside, it's going to equal negative 9I because you negated it. In other words, put a negative in front of the answer means to give the opposite of what the answer would be. Opposite in terms of signs. Okay. In the next example, we have the square root of negative 20. Negative 20, regardless of whether it's negative or positive, it's not perfect, but it does have a perfect 4 inside of it. So what we can do is take out the perfect 4 as well as take out the I from the negative 1. So you can look at it in this manner. The blue part are perfect squares. The negative 1 is a perfect square. The square root of that equals I. The square root of 4 equals 2. So what you have that's going to come out in front is 2I. And then radical 5 has to remain underneath the symbol because it's not perfect. So that leaves you with an answer of 2I radical 5. Continuing with simplifying square roots of negative numbers, here we have, for the first example, the square root of negative 3. Regardless whether negative 3, 3, whether it's positive or negative, it's not perfect. So you would not be able to remove it from the radical symbol. But you can remove its negative 1 factor, because the square root of negative 1 equals I. So simply take the I out, and what you're left with is the positive 3 underneath the radical symbol. So your answer then would be I radical 3. Moving on to the next example, 45 is not perfect, but it does have a perfect 9 inside of it. And we could also take the perfect I out of that as well, because the square root of negative 1 we know is I. The square root of 9 is 3, so what's going to come out in front is 3i, and we're going to multiply that with the 4 that's already out there, and the 5 is going to have to remain underneath the symbol because it is not perfect. So that's going to leave you with an answer of 12i radical 5. And there you have it, simplifying square roots of negative numbers.